I'm Piotr. Welcome to Daily Elastic Bytes. In the next few episodes, we're going to talk about OpenTelemetry for Java. We're going to cover traces, metrics, and logs. In this one, let's start with traces. OpenTelemetry can emit so-called signals to help us understand what is going on with our system. For Java, these signals are traces, metrics, and logs. Tracing, which in full form stands for distributed tracing, helps us figure out how certain actions are handled in pieces of our system. There's nothing preventing us from tracing a single or isolated program, yet the tracing really shines where we're dealing with a distributed system consisting of many interconnected services or microservices. By combining activities recorded in each of them, we can understand way better how, for example, user requests are handled end to end. Usually, the traces are presented in the form of waterfall diagrams. They consist of elements called spans, which represent individual technical or business actions. Each trace consists of a parent span, like this one, and any number of child spans. Apart from technicalities like span ID, they also tell us where, when, and what happened. They can also carry custom data, which we'll cover in the next episode. If you did set up the OpenTelemetry demo like described in one of the previous episodes, you should be able to find them, the traces, in Applications Traces menu. As you can see, investigating them can tell us what's happening in the system as a whole. Okay, but how do we get such nice diagrams for our own Java programs? It should be quite straightforward, because with Java we can benefit from so-called auto-instrumentation, which means that we can run our Java program with OpenTelemetry agent, which is able to capture the essential information without touching the source code and send it somewhere to be received, processed, and visualized. The program I'm going to instrument is the legendary Spring Pet Clinic. If you don't know Spring, don't worry, it's going to be used just for demo purposes. Please keep in mind it has no knowledge about OpenTelemetry. The instrumentation is happening at startup and requires no additional dependencies in Maven or Gradle. To receive OTel signals, I'm going to use Elastic Cloud, as you've just seen. It all begins at the moment when we want to start our Java program. When I have the jar at hand, I need to set some extra flags or environment variables, and last but not least, the OTel agent itself. As for the instrumentation agent, I'm going to use EDOT, which stands for Elastic Distributions of OpenTelemetry. Basically, it's the OTel agent equipped with some extensions developed, open sourced, and donated by Elastic, which didn't make it to the main distribution yet because it takes some time. It gives us some extra features like inferred spans or more metrics, which aren't present in vanilla OTel yet. Also, the EDOT for Java is the only one that's GA already. Before we run our Java program, we should first download Elastic OTel agent from here. And once we're done, we should follow the Get Started step-by-step guide. And the most important part here is, as you may see, to set up these two settings, OTLP endpoint and OTLP headers, to send some authorization data like described in here. To get these, I go back to Elastic Cloud, click here Add Data. Now I select Application, OpenTelemetry, and Java, and I click this Create API Key. So I have the API key and the APM server URL. With these, I can go now to my terminal and prepare a command like this. So as you can see in my environment variables, I'm setting OpenTelemetry endpoint, which I copied just like the headers, and that's authorization API key and the key which I copied. Then as the exporters for metrics and logs, I'm going to use OTLP. I'm also going to set some extra resource attributes, and that's really helpful to discriminate services one from another. So I'm going to set it's going to be Pet Clinic in this version, and of course the deployment environment is development. Also, I can set some extra flags which might be EDOT specific, like for example this OTel inferred spans enabled or any other OTel settings. And at the end, there's nothing more but just regular Java command. So I'm going to run my program using Java and the -jar and the jar which I have just built using Maven or Gradle. Then I'm also going to use some extra properties should I need any. And of course, I toss the Elastic OTel Java agent, which we have just downloaded seconds ago. So after running this application, yes, we can see it running. It is important that it's actually doing something so we can have any activity that we want to observe. So let me just go back to browser. Let's open the Pet Clinic application, and maybe we should try to add a visit of Harold's pet, which is this lovely Iggy wizard. Iggy needs more hugging, so now we've done something, and let's try to see if this activity has been recorded and sent to our observability backend. So let's go back to Kibana and let's go to applications and traces. And now we should be able to see something. As you can see, there's quite a lot of things happening. Transaction I'm looking for is, in this case, is this post request which creates a new pet visit. And now by examining this transaction's details, you can see how long these transactions take and what they consist of and how long each of these parts is doing. And by having such data at hand, you can easily spot problems even before they appear or impact badly user experience. And that's the whole point of observability, to be able to observe how your system is behaving out there in the wild. I hope it was useful. See you in the next episode, where we will cover creating custom spans with custom data, just to satisfy our